Hello? Wow. Right. Hi to everybody. My name is Francesco Anselmo. I come from Italy. I really work in UK. I'm a PhD candidate at the University of Palermo. This is the family acronym of the Department of Research and of Environmental and Energetic Research. I did my PhD course in, and on the right side you can see the name of the company where I work at the moment. It's quite a big company, and I'm doing mainly lighting design, day lighting simulation in this context. Alright, I'm going to talk about what is the problem for lighting designers. There are some kind of software that can be used, but the most powerful is Radiant, and it has some problems as well. I will give a description of my solution to this Radiant by using Blender, within Blender. I'll show you a few applications, and then maybe if I have some more time I can show you also how it works. Alright, at the moment lighting designers need to use some kind of software for several reasons. The main purpose of using software is understanding if the lighting is going to be right, and there are mainly two problems. One is day lighting, another one is artificial lighting, and also you can work with integration with it. There's lots of tools that can help lighting designers. The main problem about them is that they oblige you to work with some kind of regular geometry. They have crappy interfaces also. They oblige you to use Windows. So I really didn't like very much using them. The only thing that they're very good at is you can have very nice catalogs of photometrics, and you can also have very nice specifications sheets coming out of them. So there's pros and cons. Maybe the limitation with those kind of software is that they can only use the radiosity method. Well, they usually use the radiosity method. While we have a very versatile software available for free and also as open source. This is called Radiance. It is a ray tracer. Maybe some of you know it. Is there anybody who uses Radiance in this? Okay, not so many. Okay. Do you know anybody who knows about Radiance? Oh, right. Okay, some of you. That's perfect. Okay, Radiance is a very nice software. It's quite difficult to be learned. Compared to the other ray tracers, it's a little bit more difficult because it does not a kind of standard language, and the scene gets specified into several files, and also it is based on physics. So you need to know a little bit of physics before using it. A few characteristics. It is composed by more than 100 programs which interact together. So when you start using it, it's like you're in front of the shell and you have 100 binaries and you don't know what to do with them. Each one is for a very tiny part each one does a very special and small part, and then you can combine them in the pipeline and get your simulation done. This is I'm sorry, it is in Italian. It is a kind of flowchart of what is the way you usually start with building your scene. You probably start with a CAD program, then you have a 3D model. You may use a sort of import filter. You add materials and geometry and lights. Then you describe your scene. You compile the scene into a binary tree, and then you can either choose to have an interact view with our view, or to do some kind of batch render without picture. Then you have a picture, and you can visualize it in also. Then you can also do some kind of different analysis on it, like this one, for instance. The very particular thing about Radiance is that it is based on visual perception, and the way it models light is it models the actual interaction between optical properties within materials and light sources. So if you specify a light source, you specify the whole photometry of the light source. Usually 3D software, even like Blender or in any kind of ray tracer. There are very big limitations on the type of light source. You can have spotlights, you can have sort of point light source that emits in directions, but you cannot really control photometry. So the way intensity goes in all the directions. While with Radiance you can import photometric files and then you can run the simulation. And the photometric file includes intensity distribution curves so that you can use them within Radiance. The other thing is that Radiance model uses the radiometric system of units for the simulation, so it accurately models the light phenomenon, and then it adds visual perception filter if you want to visualize the picture, so you can really have a sort of feedback of what the image is going to be seen with the human eye. You can also, the filter that you see, the kind of Gaussian curves on the left, just below the eye, are the visual response curves for the human eye, and the one that has the peak on the right is the one it is the averaged one for daytime viewing, while the one on the left is the one on the right is called photopic, while the one on the left is called scotopic, and is the one that is used during night. When the lights are dimmer, so that's why we, for instance, see everything like bluish during the night, because the peak is more close to the blue area. With Radiance, you can also filter the picture so that you can get a visual response for the human eye, or maybe you can also do it for animals if you like. But there is a pre-compiled program that there is a program that helps you filtering the picture with this VLambda curve, or you can just post-process the picture in order to get also quantitative data, like in that case there are fast color picture and Isolux contour picture that shows illuminance on in this case along the surfaces of the wood. And this is particularly helpful for lighting designs because you can compare your design with regulations, and so you can understand whether what you're going to specify is going to meet building regulation requirements or visual requirements. There really is a lot of things to be said about this, but I think you will get bored, so I will just go further on. There already are many interfaces for Radiance. There also is a Radiance exporter for Blender, which exports static scenes. My point of view when I started running my interface was that really there is no interface that copes with dynamic simulations with Radiance. So my problem was, for instance, specifying various sky conditions according to weather datasets. Also, moving camera can be quite of a pain with the standard Radiance distribution. You don't have any kind of user interface, and also those kind of interface have been very related with placing the camera. And also, what if you want to move and change the geometry or the properties of materials? You cannot do it with the standard Radiance. You need to be a programmer and to write programs in order to use it. But from my initial perspective, I was also teaching in Italy, and I wanted to help students to learn Radiance. So from that standpoint, it was I really needed something to be more visual. And also, what if I want to use parametric objects responsive to luminance, like putting a sensor and then having a blind system moving according to what the sensor reduces? That's why I started my small project, which is a very important part. So the first reason why I choose Blender is because it can do animation, so it can manage the timeline. It is open source. It is cross. Well, I probably don't have to speak about this to you because you already know about it. There also are a few negative points from the perspective of teaching in this case, mainly. That the graphical user interface is not standard, and it is not a CAD program. So, for instance, for architects, it can be a little bit confusing at the beginning, but I think that I get a very nice feeling when I first started using Blender. I get the same feeling that I got started using Radiance. I mean, it's like a sort of an adventure. And that was another reason why I chose Blender at the beginning, because this kind of positive feeling was just the same I get with Radiance. The interface looks a little bit like this. You can split your window and then you load from the file export menu Radiance exporter, which opens in the script window a little bit which puts a couple of widgets on the script window, sort of toolbar, menu bar, and a status bar, and then you can interact with it very easily. I used some pre-cooked software for it at the beginning. The exporter was initially based on work by Walter, and the GUI, the graphical user interface widgets were based on the MH, Make Human graphical user interface by Mario Electronico and Manuel Basile. So I reused the software, and it was very good at the beginning, very quick. So the way it looks like when you use it is you have your scene, then you add materials from the library, you add photometers from the library, then you can interact with Radiance parameters. There is a simple mode and an advanced mode. At the moment, only the simple mode actually works. The simple mode is meant to have very easy control tools like, I don't know, you can set up the quality, and it can be set with low, medium, and high presets. The variability, if the scene is going to have a high dynamic range, like for instance, if it is a daylight scene with some interior views, and so you see from the window, from inside, outside, then you need to set some parameters in order to get all this kind of dynamic range, and also you can choose the kind of detail, you can interact with the ambient bounces. There are also some other parameters. But actually, when you're done and you run the simulation and you export the scene, for instance, you can export it with a sort of batch rendering in order to make a high quality picture, or in order to make an animation. Or you can also export to an interactive viewer, which is the one that you see on, that pops up, and that is standard Radiance. So it's one of the few graphical user interfaces of Radiance. Here is a small view of the menus. Actually, I've added a few other options to them, so a few other, maybe if you can see later. The thing I like very much is, which is probably not really aligned with the non-overlapping idea that Blender fosters, is that you can have many windows, you can leave them open, and then you can control the different parts of your simulation, and you can fine-tune the system. Another thing that is very useful is that you can export your data to the XF, well, the luminance position to the XF, or your whole calculated data set to VTK, and so you can make this kind of interactive visualization with VTK-based simulation software. So it's pretty useful if you need to analyze quantitative data, and you can also combine them with, for instance, I don't know, computational fluid dynamic data sets, and you have a sort of built-in physics simulation view on your project, which is pretty useful for both engineers and also to show them to clients and architects in order to have a visual response to what is going to happen in the building. Well, these are the current features on the left, and to-do list on the right. As you see, that there's a lot of things I need to make, and I need to profession the libraries, I need to profession export. Another thing that I want to do is a sort of PDF output that gives you a final report on the project, so you can start with you get the 3D model from the architect, for instance, and you add your fixtures, you make your lighting design. If you have also metadata applied to fixtures, then you can export your whole project as a report, and this can really speed up the work. So if anybody wants to join my little efforts, I'm really open at the moment. I haven't released yet this interface, mainly because I'm a little bit scared about its stability, and if I'm going to leave it to other people. Maybe lots of emails, I can be flooded by emails that say, oh, this doesn't work, this doesn't work. Mainly it has been done by me for my own use at the moment. And so I know what doesn't work, what works, and that's if somebody else wants to get involved, I'm really open to it. And I also since I don't have very much time, I really need some more help. I can show you a few applications where I've used the Blender interface in order to get some results for the lighting and artificial lighting simulation. This was a competition for the Guangzhou Museum in China. We worked together with Prism and architects in London. They came out with 4 different options for the facade arrangement. They are these kind of elements, vertical elements you see on the left. They are different arrangements of a facade. They both serve as a shading device and as a structural system. And the first thing I did working with Arc was this kind of study of sun hours. So what you see on the plot on the upper right is the number of sun hours that sun rays may hit the ground floor of this exposition area. I really like to work very much for competition or for conceptual or in the conceptual part of the design of a design, just because you can give a lot of input about how to adjust the architectural model to play with light, with daylighting, in this case with daylighting, and also another reason why you want to prevent maybe light coming inside of this building is because there are going to be sensitive exhibits inside of it, and also you want to control the thermal environment. So you can also move those data to lighting simulation software. These are a few visualizations of the conceptual stage of this project. And as you see, the export, this has been directly exported from my Blender interface. So you can also add a sky. The sky can also have a luminance distribution according to standards, CIE standards. There is an organization that has standardized the luminance distribution of sky, so you can use this kind of data. And so from an engineering standpoint, it's very useful. Sorry.
Rendered with gradients?
This one is rendered with gradients, yeah.
Both?
With gradients. Both the pictures, yeah. Both the pictures. Directly with gradients. Well, I mean, as I told you, they're just conceptual ideas, so I just wanted to be very quick. This one is another option of the arrangement and the kind of output you get from the calculation. This calculation was done with an external program I wrote, which uses radians in order to track rise from each point in the grid. So you specify a grid within Blender. You have a geometry within Blender, you see materials. You specify the time of the year you want to get this kind of simulation, and then I explore the model and I manually use the model to feed it, manually feed the model to an external program that uses radians to trace rays towards the sky hemisphere, and it gets the number of sun hours the number of hours the sun is in a particular section of the sky, and then sums them up and gets this kind of picture that is quite useful. I will quickly browse through all the other possibilities that the architects came with. And at the end, so as you see, they have they're quite open, and in this case, for instance, you can get a lot of collab because the sun is it is possible from this position in that time of the year. It is possible to directly see the sun. Of course, you cannot be glad at this image, but the output that gets from radiance helps you very much because you can get a sort of halo in this case. That's and also you can get a luminance fast color picture if you like. So it gives you the idea of what kind of problem you can face in this kind of project. So at the end we came out with a few recommendations for the architect. For instance, if you see the arrangement on the right is quite effective in order to limitate the number of sun hours on the floor of this building. This one is another project in which we've used Blender mainly because the model is very huge, lots of vertices, lots of polygons. It is a new development that is going to be built in London, close to the Battersea Power Station, which is a big building with bricks, as you can see on those two pictures. The car park is quite interesting. It is a kind of spiral that goes towards the center of the Earth. It is like seven stories, and my role in this project was to evaluate what kind of irradiance, what kind of well, it was really meant to be used by mechanical engineers to make the simulation, so it was a kind of pre-process thing. And I've written a program called RADMA, which uses radiance to make this kind of map that gives you an idea of what is the kind of irradiance you get on a surface. The unit that I use in this case is kilowatts hours per square meter per year. But I can also make the same simulation for smaller part of the year, so you know what is the range of irradiances you get on the surfaces for January, February, March, or for a week, or for a season, whatever. And in this case, it was very useful to give an input to mechanical engineers to do the kind of simulation with a very detailed solution. You can also add this on grids. In this case, I just took a perspective view and then calculated what is the exposure on the. You can also make it for light illuminance exposure, so it can be useful for museums, for instance, if you have a very sensible exhibit, like a painting, and you have some kind of daylighting coming on it. You can estimate what is the illuminance on a yearly basis, for instance. So you can say how many lux hours this exhibit gets. The other nice thing about this is that it uses weather data sets. So we took the weather data sets for London, which is a series of data with which you can build the sky distribution for each time step. And then the way I speed up the process in this case is I build a sky that has the sum of all the luminances, of all the radiances, of all the skies in the weather data sets. Then I add all the suns at once, so I have a cumulative sky that is that refers to the location, and well, sometimes you can have different kind of weather data sets. In this case, I used an averaged weather data sets across I think like 50 years of measurement. So it is a very mild one. It doesn't have so many peaks, but it is still representative of the location in this case. So if I, for instance, take this geometry and use a different weather data set for Palermo, for instance, for the Mediterranean area, I can get higher values, and they are representative of the area. So it can be many different things. The third and last case study I want to present to you is the EVA extension project in Valencia, and it is quite an interesting one because this project has won the Biennale of Venezia prize for the best building in 2004. Actually, it is not a new building; it is a refurbishment, an extension of a museum that you see on the upper part. The architects Sana, they are from Japan. Kazuyo Sejiro and Ryo Nishizawa, and they proposed to add to the normal building a big box with holes. And this causes lots of problems, of course. So the company where Eric was in charge of understanding what's going to happen within this building from an environmental point of view. So visually, what we're going to expect, and also thermally from a wind analysis. And in this case, well, the picture on the right shows you what kind of problem we can have. For instance, this is a sculpture court in the on top of the building that is going to be built in this case. And the architect didn't want to have any spot like the one you see on the right side of the picture. And so my first work was to, well, these are a few other pictures, so you see the kind of the whole building on the left and the kind of spots probably you can get in this area. Since we wanted to minimize this, we did a quite detailed simulation in this case. I was in charge of writing another simulation software in this case in order to evaluate what is the contribution in number of hours we can get spots on the sculpture court or also on the gallery grid, which is this spot. And the idea we used was again the one we used for this analysis, but in this case we sliced the data set because with the holes only some particular direction of rays may pass through. So we just sliced the data set according to the orientation of the grid we wanted to study. So for instance, we proposed to switch from 14 centimeters hole to 6 centimeters holes for some part of the buildings in order to reduce the number of sun events. And the final result, well, one of the results is this. We will be able to calculate what is the contribution in the number of sun hours, in this case the average number on the left and the maximum number of sun hours on the right, from each part of the facade. And also Blender was very useful in this case because it was used to build the grid, for instance, so it was very quick to work with it, and we could really deliver this project within the time constraint we were obliged to respect. And this is another visualization of what was going to happen. This is the grid that you've seen before, the one that is able to cast. Is the one on the top right, this grid. And from this view, you can understand what is the impact of the sculpture code grid for each of the subdivision of the facade grid. This is very similar to the Gonzo Museum thing that you've seen. It's just a Sanara representation, but it is interesting to understand what is the magnitude of the reduction in number of sun hours we can get by switching from 14 centimeters diameter holes to 6 centimeters diameter holes. So the architect and the client, according to what we specified, have agreed to change the diameter of the holes for the part of the facade we plotted in this case. After that work we were awarded in this case, doing the monumental lighting for the same building, and also in this case Blender was pretty useful because it allowed us to aim the fixtures very quickly. I don't know if I'm taking much time, so only 2 minutes. Okay, so I think there won't be time for the demonstration, but if you're interested, maybe we can talk later. So okay, it was very quick to aim the fixtures and to cope with this high number of fixtures. There's more than 150 for metal halide 400 watts fixture aiming at the top of this building, at the roof of the building, and the kind of effect that you can get. This one is a right dissipation post-processed with the GIMP in order to get this kind of idea of what it's going to look like in a real context. And so you can understand the architect wanted to preserve this kind of misty effect, so that the skin is going to be translucent at night. And it was a very painful problem in this case to be solved, because you can imagine what kind of complexity it can have in order to the holes are one every 20 centimeters. So if you are dealing with a mesh model of this size, then you're going to get really stuck with both the interface and the rectoizer. What we used in this case was modeling the surface with 3 layers, and we applied a bidirectional reflection transmission function to the first layer in order to reduce the transmission of the facade in a certain direction. Of course, if you imagine a hole, you can see through it according to the direction you see it. So in this case, all the whole are in one direction, but according to the perspective, you may see through some of them, and you may not see through some of them. So this kind of bidirectional transmission function was very useful in order to model it, and passing from a simulation that may have taken like 2 weeks from one that was taken 6 or 7 hours. In this case, 1 day and a half with this kind of detail, so that you will get a license. The one on the top right is that a visualization of what is going to look like in during daytime. And here are some pictures of what is the lighting inside of the building, and also in this case it was quite useful. They just needed to enhance the current lighting system. So together with the architect, we proposed something, and it has also been quite nicely developed for this, because it was just very quick to specify the luminous position. So these are my reference, and the program will be available as soon as possible through these two websites. I hope you're not too much bored by this presentation.
Buenas tardes, mi nombre es Oscar Mendoza y soy director de Imaginario Studios, que están ubicados en la ciudad de Guadalajara, Jalisco, México. Nuestras actividades como estudios de animación comenzaron en 1998 con un cortometraje animado con métodos tradicionales, cuadro por cuadro, basado en la película expresionista El gabinete del Dr. Caligari. Tras la aceptación que tuvo nuestro trabajo en Guadalajara, decidimos realizar nuestro segundo cortometraje animado llamado Berenice, basado también en un cuento corto de Edgar Allan Poe. En este cortometraje se mezclaron las técnicas tradicionales de animación con animación digital. A inicios del 2003 desarrollé el guión de Roboto, una historia que contaría las andanzas de un pequeño robot por los Underworlds, tras la parcial destrucción de su mundo y su búsqueda por adaptarse al medio. El proceso de producción duró 6 meses y durante este periodo la idea original fue modificándose, comenzaron a surgir ideas alrededor del universo Roboto y se decidió hacer una serie de 10 historias con 10 diferentes robots, todos dentro del mismo universo. Todo este trabajo nunca hubiera sido posible sin la ayuda de Blender. Roboto y todas nuestras producciones independientes no tienen presupuestos ni patrocinios, por lo que una herramienta de esta índole nos abre las puertas y deja libre nuestra creatividad. En esta tarde me complace presentarle a este público las 3 historias Roboto desarrolladas hasta el momento. Sin más por mi parte, les dejo con las imágenes y los sonidos de Roboto. Por cierto, gracias Blender por hacer más fácil la realización de nuestros sueños.
I see trees of green, red roses too. I see them blue for me and you. And I think to myself, what a wonderful world. I see skies of blue, clouds of white, the bright blessed day, dark sacred night. And I think to myself, what a wonderful world. The colors of the rainbow, so pretty in the sky, also on the faces of people going by. I see friends shaking hands, saying, how do you do? They're really saying, I love you. I hear babies cry. I watch them grow. They learn much more. I love you. And I think to myself, what a wonderful world. Yes, I think to myself,